This one is C10H14O. It has 4 double bond equivalents. We've got a 5H in the aromatic region, C6H5. We have a 3H and a 6H. This would be likely to be one CH3 group here and two CH3 groups here. Now the decision as to whether this is two CH3s or three CH2s is going to be made pretty much in accordance with the guide that I have here. And what you can see is that due to symmetry arguments, that if you've got one peak, two peaks or three peaks for the 6H, it's most likely to be two CH3s because it's very unlikely to have symmetry for three CH2s under these kinds of circumstances. The only time we really look at 3 CH2s is if we've got 4 peaks here, because then you could have 3 CH2s being next to 3 CH3s, and we can make some symmetrical arguments for that. But in this instance we're looking here at the 6H with the single peak, so that's going to be 2 CH3s. So the total here is going to be 3 CH3s. The pieces left over, we have a C and we have an O. So that would mean that we've got the O here and the C here. So these are the pieces. Now we can put them together. The two CH3 groups here that are under the 6H, it's very likely, since there's only a single peak here, these CH3 groups are not going to be connected to a C that has any hydrogens on it. So we're looking at this kind of situation for the two CH3 groups. That would be the 6H. As you can see, they're connected to this C and there's no hydrogens on this C. The oxygen then could go in one of two places. It could go here or it could go here, and the methyl group looks like it could possibly go here or it could go over here. Now the methyl group couldn't be attached here. If it was, that would mean all three of these methyl groups would be the same, and that would be one 9H peak, and that's just not the way this is. So really there's only one way to put this together, and that is to have the C connected to the aromatic ring, have the O over here and the CH3 here. More evidence for our structure is provided by this situation here, in that anything that's going to be around 4 ppm is going to be something directly connected to an oxygen. So for example here, this CH2 group connected to an O appears at 4 ppm. If you look over here, you'll see the CH3 is connected to an O and this CH3 group is at 4 ppm.